Hello, Curran here. This video is about making a scatter plot with menus for defining X and Y interactively. This is the scatter plot that we're going to make in this video. See, it's got animated transitions, and you can use these menus to select what X and Y mean interactively. If you followed the previous videos making a scatter plot and interaction with unidirectional data flow, and you're interested in adding menus to visualizations to interactively change the visual encoding, then this video is for you. The topics we're going to cover here include creating a drop-down menu component, adopting the unidirectional data flow pattern, creating a scatter plot component, and part of that will be a general update pattern refactoring of a static scatter plot example, and finally we're going to add some fancy animated transitions. Hello, Curran here. This video is about adding menus to a scatter plot so we can select what X and Y mean. In this scatter plot here, X and Y are fixed, where X is horsepower and Y is weight, but the idea is that we can add menus, maybe drop-down menus at the top, so we can select the columns from the data that map to X and Y and change it interactively. I'm going to start by forking this cars scatter plot, and I'm going to rename it to scatter plot with menus, and I'm going to clear out the old readme here. Let's start by adding some menus. If I just do a Google search for HTML menu, actually HTML select is what we want, the HTML select tag. Here's an example select menu from W3 Schools, and when you click on it, it looks like this. So I'd like to have something like this where we can select from the columns and have them map to X and Y. So we'll have one of these for X and another one for Y. In terms of strategy here, I think we should have a reusable component, maybe I'll call it drop-down menu, that implements this structure and allows us to pass in a list of options, and also takes a callback that will be called when you select one of the options. Let's create a drop-down menu component. So back in our code, I'll create a new file, and I'll call it dropdownmenu.js. And in dropdownmenu.js, we can export a function. I'll call it dropdownmenu equals a function that accepts as input a selection and props. Just like our other components that we've made, we're going to use the same pattern here. And let's say that within the props, we have something called options. So we can say const options equals props, use destructuring there to unpack our props. And then let's invoke this from index.js. So our first order of business will be to import drop-down menu from /dropdown menu, our component. And before the code does anything else, let's just invoke drop-down menu. As a first pass, let's just add a menu to the body element. So we can say select body. This is going to be our selection, the first argument. And then for the props, we can pass in options as, let's just use a simple array of like A, B, C, just as a test to get this going. Oh, that should be options with an S. So how can we implement this component? Well, let's review this example here. There's an outer select element. So let's start by creating that one. And I'm just going to copy this for reference. And in our drop-down menu.js, I'm just going to paste that in a comment just so I can see it. For our outer select element, we need to use the general update pattern special case for a single element. So I can say const select equals selection.select all select dot data, and we pass null, an array with just one element, null. Then we can say select.enter.append, select.merge, select. And since we're going to use this later, we should actually reassign select. So I'm going to say let select equals this, and then we reassign select to be the merged enter and update selection. Now we know that select will contain only one element all the time, no matter if it's the first invocation or a subsequent invocation. And we can move on to creating these option elements within the outer select element. We can say select.selectAll, option.data, and what do we want to pass in here for data? I think it's our options array. So .data options. And I think I'll call this data join option. And here we need to use the general update pattern, so we can say option.enter.append option.merge option, our variable. And once we've got this, we want to set the value attribute and also the text inside of these option elements. So for the value attribute, we can say .attr value is a function that takes as input D, one of our options, for example, A, B, or C, and we can just return D. It's just going to be that string as the value attribute. And similarly for the text, that's just going to be a function of D that returns D. I think this should be working at this point, but I'm not seeing the menu, so I'm going to inspect the DOM and see if that menu is there at all. Within our body, we have the SVG, the script tag, and there it is. There's our select, but the thing is it's off the screen, but the DOM structure looks correct. We have three options, A, B, and C. I think what we want to do here is move this DOM element to come before the SVG so that it appears on the top of the display. See, if I just move it like this in the DevTools, it appears on the top. See that? There it is. But also notice the SVG gets cut off because it goes a little off the screen there. Let's make that same change in our code. In our index.js, see, we're selecting the SVG that already exists on the body from the HTML template here. So why don't we do it this way? Let's introduce a div right here, and this div can have an ID of menus. We can put our select elements in here, and that should make them appear before the SVG. So over in our index.js, instead of selecting body, we can select the element with the ID of menus. And you know what? We can refactor this to be more idiomatic D3, where we can select the menus first and then say .call and pass in drop-down menu as the first argument and our props as the second argument. That does just the same thing. And our SVG now is going off the screen a bit. So I think what I'll do is I'll just change the height just to a hard-coded height, maybe 480, just so that horsepower doesn't go off the screen there. And I would like to make this menu a bit bigger, so we can do that in styles.css by selecting on the menus div and just setting the font size to be a bit larger. Well, that didn't quite work. But if we make the CSS more specific and we select the select elements, now it becomes bigger. That's a little bit too big. I think I'll make it like, I don't know, 2.3 EM. Maybe 2.5. Horsepower is again off the screen there, so I'm going to go back and tweak the height one more time. 450 looks good. All right, we've got our menu, but when you click on it, the options are huge. So just to fix that, I'm going to add a little more CSS. we're going to select Menus, select Option, and set the font size to 1 REM. This is relative to the root browser window, as far as I understand. Now these are a reasonable size. And by the way, if you use EM here, it doesn't work, because EM is relative to the parent. But anyway, now that we've solved this problem, we've got a basic working menu, and it's not the best, it doesn't have any label, but I would like to push through and make it so that this menu controls the x-axis of this visualization, and then circle back around later and make it, have a label, and also add another menu for y. As the next thing we do, why don't we make it so that the options of this menu are the columns available from the dataset. Over in index.js, we have the data available in our render function. And since we derive this data from a call to d3.csv, we should have data.columns available. So in our render function, let me just try that. I'm just going to say console.log data.columns, and let's see what we get. There they are. There's our columns. So this is what we want to use as our options for the drop-down menu. So let's do that. Let's move this logic that renders the drop-down menu into our render function. I'm just going to copy paste it right there, indent it. And then data.columns we can use as the value for the options right here. Now we can see that the menu contains the different columns here. What we need to do next is write some code that knows when we have selected something from these options. And we want to be able to pass this in as a callback when we invoke this component. And I think I'll call it onOptionClicked. And this will be a function that takes as input one of our columns. And for now, let's just console.log column. So we've defined this new prop. Now in our drop-down menu component, let's unpack that from the props and add it as a callback somewhere in here. And I always have to do a Google search for this one because I can't remember it. It turns out it's the onChange event. And this listener needs to be added to the select element itself, not any of the options elements. Back in our code, we can access the merged enter and update selection for our select element, and we can say .onChange. And for the second argument here, this is going to be a function, and I just want to see if we can get at the selected value somehow. So I'm going to say console.log, and if my memory serves me right on this, we can say this.value, but in order to use this, we can't use the fat arrow, so I need to use the function keyword to preserve the value of this that gets passed in. So I'm going to say function like this. Now if I make a selection here, let's say horsepower, horsepower should be printed in the console. And sure enough, there it is. All right, so far so good. So what we want to do is invoke onOptionClicked and pass this .value like that. Now that we're passing the value into onOptionClicked, over in our index.js, this code should be executing now. So now when I select horsepower, horsepower should again be output to the console, but by this code instead. And sure enough, there it is. Oh, and it looks like we have an unused import. That's useful. I think I'll delete that format import then. All right, so we have completed our drop-down menu component. Now what we need to do is sort of re-architect this program so that inside of this callback, we can set the state and then invoke the render function again with the new state of the selected column for the X value. let's adopt the unidirectional data flow pattern. We're going to use the unidirectional data flow concept here, where after you interact, the event listeners get triggered. We've got this far. Now we need to set our state, change our state. And that state feeds into the render function that renders everything, including the menus and the scatter plot. And to work correctly, we need to use the general update pattern all throughout the stuff inside our render function. The first thing I'm going to do here is make it so that our render function doesn't take anything as an input argument, but rather we store the data as part of our state. So I'm going to say let data doesn't equal anything in the beginning, and then down at the bottom of the file, when we load the data, we can say, all right, data equals data. We have a name conflict there. So I think I'll call this, loaded data. And then we can set data equal to loaded data, and then do our parsing after that. And then we can just call render and not pass in any data. So we've implemented the unidirectional data flow idea for the loading data part in here. The next thing I'm going to do is make it so that when we select something here, we store that as part of our state and render the scatter plot based on that state. So back up at the top of this file, I'm going to introduce another variable that's going to be part of our state, and we can call it xColumn. And this callback function here, I'm just going to extract that to another variable. Let's call it on xColumn clicked. And outside of our render function here, we can define that. We can say const on xColumn clicked equals, and I'm going to paste what we had earlier. And instead of console.logging the column, we can assign xColumn to be equal to column, and then invoke our render function. Now we need to use the value for xColumn inside of our render function. In our render function, all the logic for this scatter plot is right here. I would like to refactor that into a component, but first let's just get it working. Instead of just returning d.horsepower every time, we can return d at xColumn. And initially xColumn is undefined, so this is what we're getting here. But if I do select something like horsepower, it updates. See that? But if I select another thing, it just adds more points. And this is because we're not using the general update pattern. That's something we need to change. What I'll do next is make a component for the scatter plot, so we don't have all this logic cluttering up our top-level render function. Let's create a scatterplot component. So I'll make a new file. I'll call it scatterplot.js. There we go. Click OK. And then in scatterplot.js, I'm going to export a function called scatterplot. This is going to use our component pattern where we take as input a selection and props. And in the body of this function, the first thing that we can do is unpack our props, but I'm not sure yet what our props are going to be. So going back to index.js, I'm just going to wholesale copy everything that is relating to our scatterplot and just move it into scatterplot.js like that. For this to work right, we're going to need to refactor our scatterplot code to use the general update pattern throughout. Starting from the top, let's take title as a prop, and we're going to have to compute this from our selections from the menus eventually. But first off, in index.js, well, we need to actually invoke this scatterplot component. I'm just going to paste that title for now as a reminder. We need to add that as a prop. And I'm going to import scatterplot from /scatterplot. And in our render function, after we invoke the menus component, we can just say svg.call, because it's going to end up as our selection inside the component. And we can just call scatterplot. And the second argument will be our props, and that's where we can put the title. And for now, I'll just use this same title. We're going to have to change it later. All right, we've got our basic setup here. Let's go back to scatterplot.js and see what else we need. I think all of this stuff makes sense as props. The X and Y values, the circle radius, the axis labels, and the margin. These could all be props. So I'm just going to paste that here and go over to index.js and paste that here as well, and just going to reformat everything so that it makes sense. All we want to do here is unpack these from the props. So we unpack X value, X-axis label, Y value, circle radius, and Y-axis label and margin from the props. And while we're still in scatterplot.js, I'm noticing we're going to need width and height, so let's unpack those from the props as well. And I'm going to copy those new ones, width and height, over to index.js. So here we're invoking our scatterplot. We're going to need to pass in width and height, and I'm just going to reformat all this other stuff so that it makes sense in this object notation. So instead of const x value equals this, we can say x value colon is defined as this function and then separated by a comma. And then do the same for x-axis label, y value, circle radius, y-axis label, margin, and width and height. Going back to scatterplot.js, let's see what else we need to do here. Of course, we need the data as well, so we can unpack that from the props. And back in index.js, we can pass in data as well. All right, now we're passing in data. Back in scatterplot.js, what else do we need to do here? Everything looks good up until line 28, where we're referring to SVG, which we should not do. We should just use selection that's passed in. So we could say selection.append g. And the strategy I'm going to use is to just get it to work first, get it to run, and then do the general update pattern refactoring. So let's see what the errors are in the console. Scale linear is not defined. Okay, that makes sense because we're not importing scale linear from D3 in this file at all. So what I'm going to do here is go back to index.js and take all of our imports from D3 and just use them in scatterplot.js. So I'll just paste those there. All right, that seemed to solve all of our errors. So now if we can select horsepower, it plots horsepower, and now we're left with the general update pattern refactoring. All right, so where's our DOM elements? Here's G. So instead of just selecting a new G all the time, we can say selection.select all. And I don't want to use G here because there are nested group elements. We should use a class to be more specific. I'll say .container because it's going to contain everything else. We can say .data, an array with just null. Then we can say g.enter, .append, a group element, .merge, and we pass in G, the update selection, to merge. And then I'll indent this line .attr. And just so this line doesn't get too long, I'm going to reformat just a bit. Yeah, that looks reasonable. And because we're appending group elements to this parent group, we need to use the nested version of the general update pattern. That means we need to capture the enter selection. So I'm going to say const g enter equals g.enter.append g. And then here we can say genter.merge g and then set attr there. But we forgot to set the container class here. So let's do that. g.enter.append g, and we set the class with .attr. Class is container. All right, I think we're good with our section about g and gEnter. Now let's move on to the axis groups. For y-axis g, we're going to want to use gEnter. So we can see gEnter.append a group element, but because we're going to have two different group elements, one for the y-axis and one for the x-axis, I think it's actually a good idea to use a class here. So we can say .attr class, and let's use the class of y-axis. And then we use the nested version of the general update pattern. We can say .merge, and then we can select the existing y-axis from the G selection, which is the update selection. So we can say g.select .y-axis, and on this merged update and enter selection is where we can call the y-axis function. And after we call the y-axis function, this is also where we can say select all .domain.remove to remove the domain lines. I think this should be running. I'm curious, what are the errors? Oh, I've got a typo, .attrr. Here it is. Change this to .attr. All right, we've got our y-axis. Fantastic. For the y-axis label, we have yet another level of nesting that we're going to have to deal with. So from this block here, we're going to need access to the enter selection for the y-axis. So let's follow the same convention as above, where let's assign y-axis g to be the update selection, and then have a new variable, y-axis g enter, equals this logic that we had for the enter selection. And this statement can end here. And for invoking the y-axis function, we can say, all right, y-axis g dot merge y-axis g enter dot call, and so forth. All right, now that we have y-axis g enter, we can deal with this block here and use the nested version of the general update pattern again for another level of nesting. So let's make a new variable, y-axis label text equals, and here we can use y-axis g enter dot append text, and all the constant things we can set on the enter selection. And I'm going to set x on the merged enter and update selection, because if the margin changes, then the inner height will change. So after all these constant attributes are set, we can say .merge y-axis g.select, and keep in mind this is the update selection, so we're going to select the existing axis label elements that have that class. All right, there it is. Wait, it has appeared. And if we change this, it looks like there's just one instance of this DOM element still, which is what we want. All right, that's how we can use the nested version of the general update pattern for our y-axis and our y-axis label. Now let's do the same thing for the x-axis. The easiest way to do it here might be just to copy these blocks from above and then change y to x where needed. So that's what I'll do. I'm going to copy paste that whole block, and I'm going to leave 2 spaces because this is a different section really. And I'm going to separate our old code there. And I'm just going to change y to x. All right, I'll just replace all the y's with x's. The only thing that's really different about the x-axis is that we've got this additional transform to push it to the bottom. So I need to add this logic over here after we call, or it could be before actually. Before we call the x-axis function, we can set the transform attribute here like that. Now we can delete this logic, and we're also removing the domain line, so we can remove that logic too. All right, now this whole block of code that deals with the x-axis should be in working order. We're not seeing any x-axis though because the x-value function isn't properly defined yet, but if we select something from this menu, now the axis shows up and so do all the points. And if we change this menu, see the axis updates, but the points don't. So let's move on to the next section here, namely our x-axis label. So I'm going to use the same approach and just copy paste this code from above and change all the y's to x's. Now we can take a look at these constant values. See here y is 75, so I'm going to set y to 75 up there. X is inner width divided by 2, so I'm going to set that here. And setting the transform and the text anchor, we don't need. That's only for the y-axis. All right, I think this block is complete, and we can just delete this old code here. All right, now we're done with this whole block that deals with the x-axis. Now, all that we're left with is the circles and the title. We just need to use the general update pattern here because what happens now is we're just using the enter selection, so it just renders once, and if we change this, it doesn't update the circles. So I'll make a variable for the data join, const circles equals g.selectAllCircle.data. That statement ends there. Then we can say circles.enter.append circle .merge circles. And now if we select things from the menu, the circles update. This appears to be working, but there's something subtle, which is that we're using G here. And G is actually only the update selection for G. So we need to use g.merge gEnter, as a matter of fact, and then select the circles on that one. See, now we're getting the circles on the first invocation, which we were not before. The last thing we're left with here is this title. So just to see what it is, I'm going to say gEnter.append text. It says cars, horsepower versus weight. But what I'm thinking is that this title could actually be replaced by the menus, where we could say, you know, one menu versus another menu. So I'm just going to delete this text. And without a title, we can delete the associated CSS. There it is, the title, font size and fill. We can just delete that whole section. All right, we have completed the desired functionality, which is you can select something from the menu and the visualization updates. But there's a couple loose ends that we need to tie up. Namely, this is not updating here, which is the label for the x-axis. So let's go back and change that. In index.js, when we invoke the scatterplot, x-axis label is defined right here as horsepower. So we can just change this to be x column instead. So now when we select from the menu, it updates accordingly. And I'm noticing we have title defined, but we don't need it because we removed the title. So I'm going to delete that from here. And I think we're unpacking that from the props in scatterplot.js. So I'm just going to delete that there as well. Another loose end is that we're not capturing the initial value of the menu, which is mpg. So let's fix that. Over in index.js, we can initialize the x column at the time that we load the data. So when we do load the data, here is where we can say, all right, the x column is equal to just the first element of the columns array. So we can say data.columns at index 0. All right, now we have the initial value, MPG, and when we change it, it updates. All right, now let's move on to adding another menu for Y. Our first order of business is making it so there's two menus here instead of one. So let's go back to the top to index.html and see how we're doing this. The easiest way to do this might be to have two divs inside of this div, one for the X menu and one for the Y menu. So I'm going to go ahead and do that. Inside the menus div, we can have another div that has an ID of, let's say, X-menu, and we can have another div for the Y menu. And the convention for scatterplot titles is usually whatever the Y is versus whatever the X is. So we can put that right in between these divs. We can say vs dot, which means versus. And what's happening now is that this menu is getting appended to this div, but what we want to do is invoke our menu component twice, once for Y menu and once for X menu. So let's do that in our index.js. Down in our render function, we're saying, all right, select menus, but what we really want to do is say select, let's say, X menu. And then I'm going to copy paste this block and invoke it also for our Y menu. All right, now we've got two menus, one for X and one for Y. I'd like to address the positioning and the styling of these, though. What I'd like is that these should appear, these should flow from left to right on the top. To do that, I think in index.html we should use spans instead of divs. So if I change this to be span, and then not span. All right, see now the VS appears to the right. We can make the second menu a span as well. All right, now everything is going from left to right. The VS in the middle is a bit small though. Let me use some CSS to make that a little bigger. Let's add a new block to just select menus, and then in here we can set the font size, which should apply to the text. Okay, that made the VS larger, but it also made everything else larger. I think we could just use REM inside here. Yeah, there we go. All right, that looks pretty good, but I think I'd like this to be centered horizontally. And we can do that by, on our menus div, we can set text-align to be center. All right, now our menus are centered horizontally. See that? Now all we need to do is wire up our Y menu just the same way we did for the X already. So let's take a look at index.js and see what's going on here. See, we're passing in on X column clicked to both of these menus. But let's make a new function called on Y column clicked and pass that in to our Y menu. And what I can do here is just copy paste this logic, rename it to be on Y column clicked, and then change Y column to be the selected column, and then re-render. And we don't have Y column defined, so let's declare that up here. We can say let Y column, and then we can use Y column when we invoke the scatterplot component. See, here's the Y value. Instead of just returning d.wait, we can return d at Y column. And instead of just passing wait as the label, we can pass in Y column as the label. And we're seeing some behavior here which indicates that Y column is not initialized to be anything. So let's initialize Y column the same way that we're initializing X column, at least for now. We can say Y column is the first column from the data.columns. All right, now we've got MPG versus MPG. And if we select from this menu, it changes Y. And if we select from this menu, it changes X. All right, this is awesome. This is pretty much, what we had dreamed of here. And I love drop-down menus because you can actually use the arrow keys to very quickly scroll through all the possible options here. So it's a nice way to sort of fly through the space of combinations and see what you see. As a finishing touch here, I'd like to add some animated transitions on these circles. So let's go back to scatterplot.js and take a look at the code that renders the circles. We can just add .transition here. And now, if we change X or Y, it happens in a transition. See how those dots move a little bit? The transition's pretty fast, so let me just slow it down. We can add .duration and specify, say, 2000 milliseconds, which is 2 seconds. Now if you change X or Y, it happens over a 2-second period. Doing it this way lets you keep track of the circles. See, without the transition, it's just a jump cut, and you can't keep track of where the circles are coming from and where they're going. But if you add an animated transition, you can clearly see where the circle comes from and where it goes to. And one last thing I want to add here is the usage of delay. Delay can be different for each element, and you can give it a function that takes as input the data element D and also I, the index in the array. And if I return, say, I times 1000, that's going to make it so that each dot appears with a 1-second delay between them. If we make it I times, say, 10, then we have this nice sort of spraying effect, and it takes some time for all of the dots to adjust. So if you change one of these X or Y from the menus, it changes slowly like that over time. One issue we have here is that when it first loads, all these points sort of emanate from this point here, which is sort of arbitrary. And that happens, by the way, because when the transition interpolates the CX and CY, it interpolates them from the default value of 0 and 0. Let's make them emanate instead from the center here. We can do that by, on the Enter selection, setting the CX and CY attributes. We can set CX to be inner width divided by 2. See, now it's emanating from the center horizontally. And we can copy paste this logic and set CY to be inner height divided by 2. Now it emanates from the center. I'd also like the radius to start at 0, so we can say .attr r is 0 on the Enter selection. Now the circles are really spraying from the middle, starting at radius 0. It's kind of a boring initial display here, so what if we initialized X and Y to be different? Let's initialize the plot like this, where the X is weight. That's at index 0, 1, 2, 3, 4 in the columns array. So over in index.js, after we load the data, we can initialize X column to be columns at 4. Yeah, see that? The plot is correct, but our menu doesn't show the right thing. That's because we're not passing in X column or Y column to our menus to say that they're selected. Let's do that. Let's pass in something like selected option. For the X menu, that will be X column. And for the Y menu, that will be Y column. Now what we need to do is use this selected option prop in our menu component to set the default selection, the selected option. We can do that over in dropdown-menu.js by first unpacking this new prop, selected option. And for the options here, we can set an attribute of selected. So .attr selected. And this should be true if D is equal to the selected option. So the function here will be D is the input, and the output is, well, is D equal to selected option. That didn't seem to work. It looks like that made everything selected, meaning it defined the selected property for all of these to be either true or false. But what we want is that it should just set the selected property to exist if this return value is true. And we can do that using a different part of the D3 selection API, namely property. All right, that seemed to work correctly. See, now it's MPG versus weight. All right, that's how we can set the initial value for these menus. As a final change, I think I'll just get rid of this white space here by going into index.js and tweaking the margin. We can change the top margin to be, say, 10. There we go. All right, I think this is our final product here. All right, that's it for Scatterplot with menus. Thanks for watching. Take care.